Hello, good morning to everybody. I am Danilo Gipponi from EVD Technologies. And before I start, I want to spend just 2 words on the title. So because we had to submit the abstract early in the year, we knew Z15 was in the air, but we couldn't use for the title because we didn't know exactly when the announcement could have been done. And so we decided to go for this title. The real title of this paper should be ZOS Capacity Planning for Z15. So it will be really focused on the new technology on the Z15. And this is what I'm going to talk today. So after the introduction, I will spend some words on the new cache architecture, then some words again on the benchmarks and some consideration on the benchmarks. And then the major part is on the new counters and how to define the RNI and CPI, the usual stuff if you are in capacity planning, but specifically for the Z15. Okay, let's say that the major things that are affecting our world right now is the TailorFit pricing adoption, because IBM announced this very interesting new way of pricing, and companies have to decide really whether it is exciting, yes, no, maybe, and there are a lot of consideration about it because the way it's been announced, it will start with a baseline, which is last year consumption. But practically, the way we were used to, people, many companies would just tune the peak hour, and everything that was out of the peak hour was, let's say, space granted for free. And so they could run all kind of stuff that was not useless, but anyway, it didn't matter. The cost wouldn't change. So they had a lot of capacity to run things without really thinking much about that. Now, because of the TailorFit pricing rule that they start from last year consumption to define your baseline, so how much is going to cost one MSU, I already heard companies that say, okay, if we are going to think about TailorFit pricing, we better start doing some real tuning and spend some time trying to lower the MSU running outside the peak hours before we go to the new pricing. Anyway, TailorFit pricing is not the main talk of this paper, so let's go forward. In September, IBM announced the Z15 machine. Again, it was in the air. We were waiting for that. And as usual, it's very exciting. I would expect some great benefits for the companies. Okay, as I said before, I will focus on Z15. Again, there are a couple of things that are part of the announcement of the Z15, and again, I will not cover this in the presentation. So there is the ZADC evolution, and there will be no words about that. So for the next accelerator unit, you have to find it somewhere else. And again, also for the new cryptographic function. One thing is that in the section of the counters, I will say that there are some new counters that were explicitly put in place to measure how good it is or how it's working, the cryptographic, the CPA, ACF. And the other thing that was mentioned also yesterday in a Martin Parker presentation is the use of SMT on sub-engines. Now, this is now announced officially. Mark said that it was already there on the Z14, but practically nobody knew because it was not announced. And the only consideration I put on this specific thing is that it looks to me, and again, this is my own thinking, that SMT could be used on any kind of engine. So I would expect that sooner or later, also for the general purpose, SMT will become an option. It's not yet that the case. IBM knows why, I don't. But I think from the technological point of view, it could be enhanced. Right now, and as usual, let's say, if you are interested, there is a paper, literally a paper, so a document written that will talk exactly about the presentation. So it's, in practice, it's the other way around. We first wrote the paper, and then we made the presentation out of the paper. Maybe there will be a third section, and the maybe is because there is a lot of excitement around, but we do not know yet of any company that already implemented the Z15. So we know of many companies that have a plan that in January is going to happen and things like that, but we don't have any real user experience yet. So right now I'm talking about the consideration that we made out of the theory, out of the manual. No practical experience yet. Okay. Z15 is the third step of a new technology cycle that started with the Z13. Now, if you remember the Z13, let's say that it was a partial success. That is, if a company that was using a Z196 would move to a Z13, they were very happy. They could see the advantage. Companies moving from EC12, some did and some did not. It depended on many things. And anyway, one thing that was quite clear with the Z13, if you remember, new topology tools appeared that could be used in order to see what was the impact of the weight you would use in your configuration on the topology of the, let's say, how the different engines would be associated with the helpers. So the vertical height and the vertical medium. And again, a very, very small change could affect this dramatically. So at the time of the Z13, especially the IBM guys that were going to do the analysis before the migration would happen, they had to take care a lot about that. Now, my comment, this thing is not disappeared. It is still very important. The point is, it doesn't affect it in such a dramatic way as it was with the Z13. So with the Z13, it was very important to be very accurate and precise. With Z14, this thing disappeared. And with Z15, it's even better. But if you are really looking for savings, I would try and see whether the weights that I've right now on my own shop are really doing something unexpected. Because again, with a very, very tiny change, you can really change the behavior of the machine. But we will talk about this also later. Again, we don't have any real customer experience yet, but the expectation we have is that people will be very satisfied with the Z15. And again, there are some consideration I will do also later. In terms of the architecture, now Z15 use more drawers, 5, they were 4 before, and single chip modules. And the processor speed is the same, and you will see also later many things are probably the same. So the architecture didn't change so much as it was between the Z13 and the Z14. But some things were added in some critical points, and I would expect this to do really a difference. And we will see what in a while. Okay, some numbers, so, and comparison. So here you see the latest 3 technologies, so from Z13 to Z14 and to Z15. So you see the processor speed hasn't changed. Other things have changed, so the max memory and things like that, and the single capacity processor. I leave this for a while, then you can download the paper if you are interested in these numbers and figures. And again, if you are interested, you can request the physical paper to me or to Nathan. So as I said before, and we will see in a while, Z14 and Z15 architecture are very similar, so there were not so much dramatical changes. So as you know probably, what is very important for this kind of technology is that when you are looking for some data and instruction, you find them in the first level of the cache, which is the one that is closest to the engine. Now, if that happens, that is called a cache hit. And in this situation, you don't waste any cycle. It's like you need to do something, it's there, you do it. Instead, if you have a cache miss, then you need to go and fetch this data in memory somewhere. And this could be very close or very far. And this is really what is going to change dramatically the results of these machines. So this is all the architecture and the scale. So it's like if you find it in level 1, that's the end of the story. Otherwise, you have to go in level 2. And as you see in the slide, level 2 is a cache that is still dedicated to every processor. So in practical terms, if you do not find what you are looking for in the first level, and you go on the second level, you waste some cycles, but not that much. From the third level, it starts what is called the nest. So with this technology, we talk about relative nest intensity. The nest is something that starts from the third level of the cache and goes on. So in practical terms, the further you have to go in order to fetch your data and instruction, the more you stay in the nest. And the relative nest intensity, which is something that we will talk about later and will explain in a very detailed way, at the end is just a number that tells you how far you have to go in the nest in order to find the data. And by definition, if you have a very high relative nest intensity, it means that the hardware you have is wasting a lot of cycle. And instead, if you have a very low relative nest intensity, then you are really using the machine very well, and very few cycles are lost on the way. And again, we will see with some slides what is the difference between one and the other situation. So from the best to the worst, it makes a difference. So if there is anything you can do in order to improve your usage of the nest, you should do it. Okay, I guess I said the first statement with other words, and as I said, the worst situation is when you have to go in memory, really, because that's, and again, the formulas later, I will use the formulas to give you an idea of practically how big is the difference between finding the data closer or in a distant place. Okay, some words on the architecture. So I said before, Z15 has 5 drawers instead of 4. Everything else is practically the same. So a drawer includes 2 clusters that share the same level for cache. The next slide will have a picture of this. So this is the description, and then there is a slide that will show you in a more graphical way, in a more easy way to understand. But the point is, the same level for cache is for the clusters. And again, it's like the closer you are to the engine, the better it is. So if you don't find it in level 3 and you go at the level 4, if it's in the same cluster, it's something. If you have to fetch at the level 4 in another cluster, again, you're wasting more cycles. Okay, the level 4 cache of a drawer is fully inclusive. So again, it's but this was the case also for Z14. And the thing that was introduced in the Z14 was a point-to-point connection instead of the ring connection that was in the Z13 that was not so much efficient. Okay, this is a Z14 architecture, and this is a Z15 architecture. So I'm going back and forth a couple of times. As you can see, it doesn't really change. It's practically the same architecture. What is really different is the size of some of the cache and the fact that now we have 5 drawers instead of 4.
So I guess you're not going to mention it, but the number of chips in a cluster, the chips went down from essentially 3 to 2.
I don't think I'm going to mention that. Thanks.
I didn't see that before. The only reason I raised it is because I think it's significant in terms of how many cores can end up on the same chip.
Well, let's say that to me what was very, what I highlighted afterwards is the fact that, for example, if you look at here, when you look at the level 2 cache, the instruction moved from 2 mega to 4 mega. So it's exactly the same, but now you have twice as much. And again, when you are at the level 2, it means that you are not in the nest. So you are not in the best position, but you are very close to it. You are in. So, and again, this later will be a reprise with looking at some numbers when you see the difference between average, low, and high RNI. You see that from generation to generation, there is a big reduction. It's like when you were with the Z13, if you were in the worst case, you were here, and in the best case, you were completely on the other side of the world, and this is reducing, which means that still the architecture is affecting the usage of the hardware, but always in a more efficient way. Because at the end, again, we will see later when we talk about the formula, the fact that the optimal value for a cache is below 5% for cache miss. So as long as you are below 5%, you are in a good situation, which means that only 5% of the situation will affect the result of the usage of your machine, which is very, very peculiar. Anyway, this is going to be spoke a little bit later. On here, I just put the 2 slides of the architecture, then the fact that many cache levels were increased, and as I said, the level 2 has doubled, and again, level 3 cache has been doubled. So all these things have done something, had an effect that overall reduce the RNI, so allows you to better use the machine. So again, this is pointed out, and this is the highlight of the difference. So, and you see, some of these are very, very, very good. So just to recap, this is taken from this manual. Workload capacity performance will be quite sensitive to how deep you go into the memory in order to fetch what you are looking for. Again, it's again the same concept. With other words, this is taken from an IBM manual. Now, just to put something based on my experience, we found out situation where, for practical reason, I speak about a customer situation, a very peculiar situation I have in mind. We told them that with a slight increase of the weight of an LPAR, they could have moved that LPAR from an average RNI to a low RNI, because of the fact that with that weight they had a vertical high, and a vertical low. So in order to have a vertical high and a vertical and a vertical median, they could have had 2 vertical highs just with a slight increase. But this was an outsourcer. And so they said, no, we have a policy, so it depends on the... so they didn't do it. So in fact, it would have been interesting to see the net effect on all the other helpers. But then again, there are considerations. Again, as I said before, if you are able to move an helper from an average RNI to a low RNI, or better, from an high RNI to an average RNI, you will see the results in terms of the overhead, because you are literally wasting cycles, spinning, waiting for the instruction to come. Okay, many other improvements have been added. The transaction look-aside buffer size has increased, and then there are been optimization in the pipeline, SMT. SMT now is a much more stable and efficient. Again, in the Z13, some companies tested it, few companies put it in production. Now there are more and more going in that direction. The bus speed, so, and again, what to me will be the real benefit, the cache latency. Again, all this information is practically being taken out from this manual, red book, so if you are really interested in exploiting this information, that's the test. Okay, new LSPR benchmarks have been published for Z15 and the newest version of ZOS. These benchmarks are the ITR ratio between the capacity of each processor and the capacity of a reference processor, which is, as usual, the old one, the 294.701. Okay, this is not important, but let's say all the others for the other machine have not changed, so what is really new is the Z15 ratio. So this is important to get the latest version if you are really looking for a Z15. And the others are still the same. As usual, and as we already mentioned before, there are 3 categories: low RNI, average RNI, and high RNI. As we said before, low RNI, it means that luckily enough you can find your information very close to the chip. High RNI means that you have to go further on in the memory. And okay, this is these are the benchmarks, and what I always point out is when you look at the difference, if we take the last line, for example, you see that if you are running a piece of hardware, let's say this is a Z15, and it's 85617JO. Now, if you have an helper that is running in a lower RNI, you may deliver more than 220,000 MIPS. No, thousands. If the same helper is instead a higher RNI, you see the difference is 7,000 MIPS. It's a huge difference. It's a huge difference when you think about it. When you really think about it, only 5% of the situation will create a situation where the machine is spinning so much, waiting for the data and the instruction to be retrieved, and this is wasted. This is cycles that are not used for practical work. So that is why it's very important to try and tune and do whatever you can to be on the lowest side as possible. There is a question.
Quick question. If I recall correctly, going from the Z13 to the Z14, performance improvements were greater in the high RNI than the low RNI. Do we expect the same going to the Z15, that the performance improvements will be greater in the high RNI and the low RNI?
Oh, let's say that, again, we don't have any real experience so far. Our expectation is that the Z15 will be a happy generation. I expect that the companies that will move to Z15 will have, let me try to say this with my words. With Z13, not everybody was happy because they had expectations that were not fulfilled in some situation. With the Z15, my feeling is that the expectations that are very high will be fulfilled. Because again, Z14 addressed specifically those issues that were raised with the new technology. And Z15 is just slightly improving it, which means that what they did in Z14 was very good. But again, what they did was not, was crucial to me, because the end effect will be that more and more cycle will be used for productive work, because they've increased all the cache memory and things like that. So I expect companies will be happy. If someone would ask me, would you move to a Z15, I would say yes. Then again, if you move from a Z13 to a Z15, I'm sure you will be very happy. You will do jumps in the ground. From Z14, probably not as much, but again, I expect this to be a step forward, really. In a way, something similar happened with the Z9, Z196 compared to the Z10 and then the EC12. If you remember, the Z10 was something that not everybody was so happy. Z96, 196, everybody was happy. EC12 was a very, very huge step forward. So again, my expectation is that people will be satisfied with this technology. Okay, in the benchmarks, there is always a PCI. The PCI is what is used when dealing with the managers, so the buying office. So it's the expected behavior of the machine. It's very close to the average, which in the end it's turned out to be the normal situation right now. So it's unlikely that you are in a high RNI unless you are a test or a very small helper with no weights and with no priority at all. Okay, so again, as usual, the MSU values are written on SMF. So whereas the MIPS value is always an estimate, you have the MSU that is instead a real measure, accurate measure, a measure anyway produced by the system. So you have a place where you know how many MSU you are using. And the point is that in the past, IBM used the MSU to do a sort of a discount. And now with the new machine generation, there is a very, very strong relationship with the MIPS and MSU. So it's like if you are lazy and you want to jump many, many steps, you can start with MSU and calculate the MIPS, or the other way around. Okay, so this is, as you can see, the MIPS versus MSU, and they are very stable. So again, there has been generation with the 196, the Z10, that this was changing from level to level, but now it's very stable. So, and again, the MSU are written on SMF. So it's something that you can say, it's not my idea, whereas MIPS is always an estimate. So, okay, when we look at the single CP capacity, let's say that it looks like we are close to the technology limit, because every new generation is not improving as much. So the capacity from Z9 to Z10 was dramatic, 61%. Then it was 33, 26, 12, 8, 12. So it means that the capacity of a single engine from the Z15 compared to a single engine or Z14 is 12 times greater, 12% times greater. So again, this is the graphical representation of that. Now, there is a set of graphs that say what I said before, and these are based on this formula that is explained here. And when we look at the graph, this is the result. And again, it's the difference between the situation, if you are in a low RNI or in a higher RNI. And again, the fact that with the Z15, it's, the difference is lower is what I said before. So let's say the technology is really improving. You can see by this, because it's much more easier to be on an average side that is where you would like to be, because that's the value that is presented to the management. So, okay. What else to say? These are some conclusions based on the previous graph. So the value of 36%, again, is based on the formula that you saw in the previous page. So it's pretty much self-explained. The meaning really of these graphs was to show up this fact that the machines are much more stable. And now, even if you do a mistake, the variability is not as big as it was before. So before, with the Z13, a small mistake, a small change could create a dramatic result. Okay, again, the same statement. Bottom line is what I said before. When you do the capacity planning, so if you are moving from your generation to the next one, what you should do is to measure the usage of your machine, calculate the RNI. That is something you can do. You have all the values to do it. It's a mathematical process. It's not something that requires any real experience. And with that, you can decide which is the right benchmark to use. So the benchmark that really represent your workload. What is really important is that you collect the record 113. I have to say on this respect that there are still companies around that do not turn it on. I don't understand why, but so if I have to give just one suggestion you bring home, if you do not have the 113 turned on, please do it. There is no significant overhead, and it's really useful. Now, the other thing is that the ZPCR tool, which is a very important step when you do the capacity planning, now has been improved. So you could send SMF data straight to it, and it will calculate the right benchmark. Even though you could do that, we suggest you do not do that, and you collect your own data and study your own behavior, because I'll show you later, this can vary from moment to moment. So maybe you send SMF, and then that's not really representative. And so you use it as a baseline in a wrong way. Okay, as we said before, the 113 counters are very important. And so you may collect them, and then using math, you can decide where you are. And it's also important to see what advantages you have before and after you do an upgrade. Yesterday, I had a paper on a situation where installing the DB2 version 12, a company had a huge improvement. And because we were measuring before and after, we could show where the improvement was and how much it was, and that's very important. And also it's important because we had situations where there were anomalies, so they could raise this thing to IBM and find out microcode patch were needed or things like that. So it's always important to measure. So And again, the 113 is not that much volume of data. Okay, a few words on these counters. They have basic counters, and the good thing is that they are not machine dependent, so they are always the same, and they have the same meaning since the very beginning. Since the Z10, they never change it. So these are 6 counters, and they are called B0 to B5, and these are the basic counters. Then there are the problem state counters, and they are also not machine dependent, and so they have the same meaning. Also, there are crypto counters that are not machine dependent. Now, on these things, new counters have been added for the Z15. So there are new columns in the SMF 113. So there are now those numbers explained here. So it's for you to know. If you really have an issue and you want to measure how your crypto processor are working, again, you have counters now, more counters that have different explanation.
So basically, each crypto function has a set of 4 counters, and another set.
Exactly. That has been added, yes. Yeah, again, they are very specific. So they are not something that you use regularly every day, but again, they are there. So if you have an issue, it's very straightforward to use them and understand what's happening. So then the interesting part is the extended counters. They used to be machine dependent. It means that the extended counters in Z10 has a meaning, the same columns has a different meaning for the next generation of machine, and a different meaning for the next generation. For the first time in history, something happened. So the extended counters of the Z14 are the same of the Z15. So there, again, probably because there were no significant changes in the architecture, so it was just the size of the cache. Anyway, let's say that this makes our life easier. Again, also in this situation, there are more counters that have been added for Z15. And the point is they are there, but they are not yet used. So it's probably due to something that will come soon, but they are not used. And then there are also empty counters, and they have the same meaning again, and 2 more were added. You can find all this information in this manual, so if you are, again, interested in going in deeper detail, this is where you can find all the information. Now, the last part is talking about level 1 miss, RNI, and CPI, so CPI, cycle per instruction. So level 1 miss and RNI, we mentioned before, are the things that you need to know to understand which is the benchmark that is representing your LPAR. So this table has been around for a while. It's very stable. So if you have, again, less than 3% of level 1 miss, and then your RNI that is produced with a formula that I will explain later, and there is a different formula for every machine, gives a number less equal 0.75, then you are in the benchmark average RNI. So that is the benchmark that best represents your workload activity. This is what I said before. The new version of ZPCR allows you to give SMF data to the tool, but if you see, this is a real example taken from a production LPAR. And you can see right now this is the level 1 miss, and you see that from time to time it may change. So in this graph we are just representing the prime shift, so based on their definition from 8 to 12 and 15, 17. And still there are days when this value is much different. And this may be because they are the first of the month or things like that. So, but anyway, the point is, when you have to project and do a study for capacity planning, you have to decide which is the baseline and which is the value that best represent your own situation. So if you just give some SMF data, you may be fall in a peak or out of the peak. And I don't know which is the best, the one that you should use. But the point is, if you know that there are peaks, you may decide that that is the place where you want to be sure that you do not fail. And again, this is another example for the RNI. So there are situations where the RNI goes up. And ideally, if you collect this regularly, the first thing you should do is try to understand why that happened. So is that a misbehavior, is a problem, or whatever it is. So again, our suggestion is to collect this data over time. Now, based on the previous table, we can say that this LPAR, because the level 1 miss is generally below 3% and the RNI is below 75, then the benchmark that should be used is an average RNI, which most of the time is the case. But again, you can measure it, so you will know exactly where you fall. How do you calculate that? So to calculate the level 1 miss, the formula is the same. So you have the basic counters, and this is the formula. So it's very, very straightforward. The RNI for the Z15 machine has to be calculated using the formula that is at the end of the page. And this is a formula provided by IBM. It's not us that decided the numbers. And again, it's like you can see from here that the more you go forward, you see that there is the level 3 miss, the level 4 local, the level 4 remote. So for example, if you find what you are looking for in level 4 local, you miss 1.5 whatever. If you go in remote, it's 3.2, it's twice as much. So it means that if you are in a situation where you don't find the data and instruction in level 4 local, but you need to go to a level 4 remote, you spend twice as much spinning and waiting for the data. Anyway, this is the formula. There are all the counters that are explained now, so where you find the data and what you are looking for. Again, I can repeat, these are the same for the Z14. So if you are used to do this kind of exercise in the past, it's the first time this formula is not going to change. And I mean, it's not going to change how you calculate level 3, level 4, local, level 4 remote, and so on. So here you have all the details and what you should do in order to find the numbers. Again, this is tool independent. You have to read SMF and then use these fields. Okay, and when you have all the things, you do the math, and in the end, you will know your RNI. Okay, the last thing I'm talking about and is the CPI. CPI is a cycle per instruction, and this is a number that represents the average number of cycles needed to perform an instruction. And this is the formula. There is not a rule of thumb for the ideal cycle per instruction. But of course, the lower it is, the better it is. It means that when you need to do something, you really don't use much cycles. Again, this is something that if you measure regularly, you know, you may say that a new generation of hardware is helping you, or if there is something which is misbehaving. So again, if the expectation is not fulfilled. again, there is not a magic number. It really depends on the workload. And this is a value that when you measure it regularly, it varies from hour to hour. This next table show you that, for example, okay, in this LPAR, which is called test 2, they haven't turned on the 113, so we don't know how many cycles per instruction. And then you may see that there are situations, depending on the LPARs, that goes from very low values to higher values, because some of them are production, some of them are test, and things again. But the very important thing is that you can measure this regularly, and again, in this other slide, we have highlighted Prod 2 and Prod 3. These are 3 LPARs that are doing basically the same workload, and we expect them to have very similar cycle per instruction. Again, our suggestion is to use them regularly, because if there are changes, then you can control the situation and see if it's normal or if it's the normal behavior. The last thing to say about the cycle per instruction, again, this is something that was raised on the Z13 with the Z13 technology. You have to count the clock speed, because a cycle is a cycle, it's not a finite amount of time. So if your processor has a speed, a greater speed, in the same amount of time, you have more cycles. So you have to take into account also the processor speed. Again, in this very specific situation, or better, if you are moving from a Z14 to a Z15, this is not an issue. They are the same speed. So even if you just forget to do it, you will get a meaningful number. But for example, if you move from a Z13 to a Z14, or from a Z13 to a Z15, you have to make sure that you use also the processor speed, so that at that point, a cycle will be exactly the same thing. So, yeah. Okay, and this is for me the last slide. If you have any comment, any questions, anyone is planning to move to Z15 soon? You, okay. You got it already?
Yeah, just not powered up yet.
I see. Well, again, amongst our customers, we have 3 or 4 that are planning to move to Z15 between December and January, depending on different companies, and that's. I see. And what about TailorFit pricing? Is something that you know that you are considering or not yet?
What's that? Oh, I'm not sure yet.
You don't know, yeah. Yeah, because again, that was something that was announced, created a lot of stir and interest among also the commercial people in IBM, and then it sort of slowed down a little bit because of the implication of. Okay, if you don't have any question, then that's the end of the presentation for me. Thanks a lot.